All right, guys, so some things we're going to be looking at today are the Pythagorean theorem. I know you all have done that. Okay, so starting with the Pythagorean theorem, we need to know that anytime we have a right triangle, C must be the hypotenuse, and we all know that A squared plus B squared equals C squared. You all have done that many times, nothing new there. However, this is something you may not have seen. Rather than me doing 4 squared plus 8 squared equals x squared, I can do a simpler triangle. Here's what I'm going to do. Instead of doing 16 plus 64 equals x squared, that's 80, and then trying to simplify that, do you know what square root of 80 simplifies to? Okay, let's say we don't.
4 radical 5?
It is 4 radical 5, but a lot of us couldn't get it that quickly. So do this instead. 4 and 8 can both be divided by 4, so I'm going to keep that in mind. 4 divided by 4 is 1, 8 divided by 4 is 2. So now I'm going to do 1 squared plus 2 squared equals x squared. So 1 plus 4 equals x squared, 5 equals x squared, take the square root, and so x is radical 5. But it's not really that x is radical 5 because what do I now have to multiply it by? So it's 4 radical 5 for x. So the problem with doing it that way is that you have to remember to multiply by that number, because all you're doing is using a similar triangle, and then you're going to go ahead and you're going to multiply it by whatever that ratio is. Okay? Isn't that easier than trying to make that 4 radical 5? All right, same thing here. I don't want to do x squared plus 22 squared. I don't know what those are. I don't know 22 squared and 24 squared. So what am I going to make it? 11 and 12. So now I can do x squared plus 121 equals 144. So therefore I'm going to have x squared equals 23, x equals radical 23, but that's not really my answer for x. What's the real answer for x? Yep, 2 radical 23. Much easier than the other way. Okay? So we're doing simplified versions on the Pythagorean theorem. Here are some special right triangles, and these are things you've learned before. For a 45, 45, 90, we should know that the legs are each going to be x. And what's the relationship between the legs and the hypotenuse?
X to the radical 2.
Right. If I forgot that, if that's x and that's x, watch what I could have done. X squared plus x squared has to equal c squared. What is 1x squared plus 1x squared?
2x squared.
So then if I take that, c is going to have to be take the square root. The square root of x squared is x. The square root of 2 I don't know. So see how that proves that pattern? That pattern has to go x, x, x radical 2. Okay? On a 30, 60, 90, do you remember this? What's the shorter leg? X. The longer leg?
X radical 3.
Yep, the longer leg is x radical 3, and then what's the hypotenuse?
2x.
2x. You don't need to write this down, but just watch quickly as I do this. Here's where this comes from. If I have 60, 60, and 60, and I drop this down, this is now 30 and 30. If it's 60, 60, 60, all these sides would have to be the same. I can call them anything. I'm going to call them 2x. Well, if this was 2x and I drop this down, it's now x. So I would do x squared plus, this is what I'm trying to figure out, this is 2x. What if I square 2x? What is it? Which is not, you guys square everything. 4x squared, right? So then b squared is going to be subtract 1x squared is 3x squared. Take the square root. See the reason why it's always x radical 3? Okay? That's where all this comes from, is from just simple geometry rules. All right, so using those. So if this is a 45, 45, 90, what's true of the legs?
X is 10.
Right? And then y is going to have to be?
10 radical 2.
Good. Okay, go ahead and do number 4 on your own. Everybody get 8 radical 2 for x and y? Do you understand why? The reason why, guys, is because this is my x radical 2 side. So I have to say my x radical 2 side equals 16. So to solve for my x side, I had to divide by radical 2. Well, if I have 16 over radical 2, then I have to multiply by radical 2 on top and bottom. And if I have 16 radical 2 over 2, that reduces to 8 radical 2. All right, this one's a little bit easier. What are x and y? This is my x radical 2 side. So to solve for my x, what's it going to be? Just 14. The radical 2's cancel. Okay, now we switch gears. We have to look at our angles. Now we have a 30, 60, 90. We're given this side. In a 30, 60, 90, that side, that is the hypotenuse. So that's our 2x side. So I know my 2x side is 8. So then what's our x going to be? So x has to be 4, and then this is my x radical 3 side. So it's going to be 4 radical 3. Okay, on this one, this is my 60 side. The 60 side is actually now, look at the way this is written. They're calling this y, right? So this is my y side. So this would actually be my y radical 3 side, would be 27. Because my short leg is actually y in this case instead of x. So then if I divide by radical 3, good, do you guys understand why? It's 27 radical 3 over 3. So y is 9 radical 3. Got to be careful with this one. So this is 9 radical 3. And then how do we go from the 30, from the short leg to the hypotenuse? Yep, you got to double it. So it's 18 radical 3. Okay, in this problem, this is my short leg. 5 radical 6 is my short leg. I want to go to the long leg. So to go from the short leg to the long leg, I have to multiply by radical 3. Just think, are you getting larger or smaller? If you're getting larger, you're going to multiply. So this is 5 radical 18. 18 is going to be 9 times 2. So then what's that going to be then for this? Right, and that's actually going to be y. Make sure you put it in the right spot. And then my x is going to have to be whatever this short leg is doubled. So if I double that short leg, I only multiply the parts that are alike. So 5 times 2 gets multiplied, and the radical 6 stays the same. Okay, questions there? All right, flip over to the back. Trigonometric functions. Trigonometric ratios just compares the lengths of two sides of a triangle. The Greek letter, what's this letter? Anybody know the name of it? Theta. So theta, T-H-E-T-A. That's what's used to represent the measure of an acute angle in a right triangle. So if I want to know the sine relationship, here's going to be the angle. For this angle, this would be the opposite. It's directly across from it. This would be the hypotenuse. This would be the adjacent. The hypotenuse is also adjacent to the angle, but it's called the hypotenuse because it's across from the right angle. So everybody's probably heard SOHCAHTOA, right? Yep. The big thing is knowing how to spell it, though. I've noticed sometimes people don't know how to spell it and then they miss things. What you can do is forget about the sine, cosine, and tangent, and you can think of it this way. Oh, heck. Another hour of algebra. So you can remember it that way. If you don't know how to spell it, think of that. All right, so sine then is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Most of you are probably pretty familiar with that, right? Okay, but you have not seen cosecant before. Cosecant is the reciprocal of sine. So if you know the sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. The reciprocal of cosine is called secant. And so it's going to be hypotenuse over adjacent. The reciprocal of tangent is cotangent, and it's going to be adjacent over opposite. Okay? So they give us a picture, and it says to find all 6 ratios for theta shown in the triangle below. Here's our theta. This is going to be my opposite, my hypotenuse, and this would be the adjacent. What do I need to know before I can find these ratios? Hypotenuse. I don't really want to do 16 squared plus 30 squared. What can I divide each of those by? 2. So I'm going to remember that I'm dividing them by 2. So now I'm going to do 8 squared plus 15 squared equals c squared. So this is 64 plus 225. That's 289. Do you guys know the square root of 289?
17.
It is 17. So this is going to be 17, but it's not really 17. What is it? Which is 34. Okay? So now when I go to do the sine of theta, I'm going to have to do opposite, which is 16, over hypotenuse, which is 34. But then I want to have it in lowest terms, so what's it going to be? 8 over 17. So now I automatically know the cosecant, it's just the reciprocal. It's 17 over 8. For the cosine, now how can I do this more quickly? Instead of doing 30 over 34, what can I just do? What did we call this before? 15 over 17, right. So this would just be 15 over 17, right? Remember how we used the reduced ones? 8, 15, and 17. It's getting a little messy in there, but 15 over 17. And so the secant then is 17 over 15. Tangent is going to be opposite over adjacent, so what is it?
8 over 15.
And then what's the cotangent?
15 over 8.
Yeah. And guys, I always do that first. Like if I'm given some triangle, let's say I'm given this triangle of 10, 24, and 26. Before I even start writing these ratios out, here's what I do. See how it's the same thing, but it's just reduced? And now I'm not going to have to reduce them over and over and over. So always do that, and it'll make things easier. How do we do this? Given the ratio for cosine theta, find the remaining ratios. So this time they told us cosine, but we have to find all the others. What could we do? Go ahead.
And the hypotenuse. Just write it in. I guess you could write it in and solve for the rest itself.
Right. So I can name my theta. So I'm just going to put my theta here. And I'm being told that my adjacent and my hypotenuse. So I want to label this. This is the hypotenuse, this is the adjacent, this is the opposite. So my adjacent is 2, my hypotenuse is 3. Do I do 4 plus 9? No, I'm going to have to do 4 plus b squared equals 9. B squared equals 5, so this is going to be radical 5. Okay, so then our sine ratio is going to be opposite over hypotenuse. Might as well go ahead and do the cosecant, but we have to rationalize. So it's 3 radical 5 over 5. The secant is going to be 3 halves.
Wouldn't that be 3 radical 5 over 5 over 3?
No.
Never mind.
Okay. Tangent is going to be opposite over adjacent. Cotangent is going to be 2 over radical 5, but then I'm going to have to do this. So it's 2 radical 5 over 5. Okay, the last thing we're doing is finding the sine, cosine, and tangent for 45s and 30s and 60s. Here's how we do this. We know every 45, 45, 90 has to go x, x, x radical 2. It might be 5, 5, 5 radical 2. It might be 4, 4, 4 radical 2. It always goes that way. So here's going to be for my 45-degree angle. There's my angle. This is going to be opposite. This would be adjacent, and this would be hypotenuse. So if I'm trying to do the sine of 45, it's going to be my opposite over my hypotenuse. Well, my x's would cancel out. There would be a 1 left on top. So the sine of 45 is 1 over radical 2. But we need to rationalize. So we're going to have radical 2 over 2. That's going to be our exact ratio. Go ahead and get out your calculator if you have it handy. Go to the mode right next to the blue key. Make sure your calculator is in degrees. Just highlight degrees. And now I want you to go back and I want you to do the sine of 45. Here's the answer, 0.707106, blah, blah, blah. Okay, now I want you to put this in, radical 2 divided by 2. See how you get the same thing? What is the exact answer? If I put 0.7071067812, is that exact?
No.
No, why not? What kind of number is that?
Irrational.
Irrational. Irrational numbers are non-repeating decimals that never terminate. They go on forever. So therefore, if I ask you for the exact answer, you can use your calculator to check, but if you give me that answer, that's wrong. That's not the exact answer. This is the exact answer. So what about the cosine of 45? Let's find the exact answer. So what's it going to be? What's my adjacent? Look right here, guys. The adjacent is x, and what's the hypotenuse? Okay, these cancel. I get 1. So what's this going to end up being? Same thing. Okay, tangent of 45. I have to do opposite over adjacent. What's that going to end up being? 1. Type it in your calculator. Check it. Tangent of 45. Okay, see how we can check? All right, now we're switching to 30 degrees, so we have to think of this relationship. So for my 30 degrees, this is going to be my opposite, this is my adjacent, and this is my hypotenuse. Across from the 30 is x. What's across from the 60?
X radical
3. And then what's across from the 90? 2x. Okay, so the sine of 30, I'm going to have to do x over what? So this is really a 1x over a 2x. What is that then? 1/2. See, we're looking for exact answers here. I'm going to check it. Sine of 30. Yep, we're right. Okay, let's do the cosine of 30 now. We're going to do our adjacent over our hypotenuse. So can you see why it would be radical 3 over 2? If I wanted to check, I would do radical 3 divided by 2. And then I would also see, is that the same thing as cosine 30? See how I can check and make sure that that's right? Cosine of 30 is the same as radical 3 over 2. They have the same answer. Okay, what about for tangent of 30? What's that going to be?
x over x radical.
Good. And then I'm going to put a 1 in front of my x. The x's cancel.
1 over radical.
Right, which would end up being
Radical 3 over 2.
good. Check it if we wanted to. All right, now when we switch to 60 degrees, that changes things a little bit because now this is going to be my angle that I'm working with. This is still the hypotenuse, but what does this change to now?
Opposite.
This would now be my opposite, and this would now be our adjacent. So I have to make that adjustment. So now to find the sine of 60, what's that going to be? Good. Can you guys understand just ignoring the x's now?
Yeah.
Cosine of 60, what's that going to be? Good. And what about the tangent of 60? Yep, just radical 3. And that's because it's going to be x radical 3 over x. So if I had x radical 3 over x, the x's would cancel and just leave me radical 3. And if you're not sure of it, guys, just check that answer real quick. Tangent of 60, is that the same as radical 3? Yes. Okay? Your quiz or test over this will be part calculator, part non, but there are going to be some things on the calculator part that you could actually check. You know, even though I asked for an exact answer, you could still check by doing that kind of thing. All right, seem pretty easy for day one? Okay, so with these, you're not going to have homework out of your book at all. It's all going to be given out